Hello everyone, in this video I'm going to go through MA162 Exam 2 for Spring 2020. This is going to be part 1 where I go through question 1 through 6. For question 1, we have 2x ln x for the integral we need to solve. And this should be pretty simple to see that it's a biparts question because this has two parts to it, right? ln x and 2x. And this is the ln x part is logarithmic, so it's perfect for the u of the pi parts and this is from the ATA, right? L for logarithmic. So I'll write u du and then v dv. Right, for u we have ln x. And then for v, that should be in blue. For v, we have 2x dx. Right, and then du is just take the integral, take the derivative of ln x, which is 1 of x, and then v is just the integral of 2x, which is x squared. Right, and then we can write the biparts, so that equals to uv minus v du. And then I can plug in, right, uv is ln x times x squared minus v du. Remember to have the dx. And then this should just be ln x squared evaluated from 1 to e minus, this would be just an x, and then the integral of that would be half x squared to e. From here, we can plug in parameters. Therefore, we have ln e times e squared, and then that will be minus ln1, which is 0, times 1, right? That's 0, that is 1, and then minus e squared over 2 plus 1/2. Right, so here we have e squared minus e squared plus 1/2. Combine these three rather, we will have e squared plus 1 over 2. For number 2, we're given a indefinite integral, and we're to find just the integration of that. So first, let's do it the integration rate, and then I'll show you how to do this if you don't know what to do. So this will be our first way. Notice the power of the x is same on top and bottom. So what I can do here is actually it's sort of like long division, but I just like can do a +1 and then -1 on top, so that will not change the value, and then I can take this x plus 1 off, right? And this will be x squared plus 1 plus -1 over x squared plus 1. That will be 1 minus 1 over x squared plus 1. Right, this makes the integral a lot simpler. So what I'm resulting with is just 1 minus 1 over x squared plus 1 dx. And this one part goes to x, right? The integral of 1 is just x. And then this part should be pretty familiar if you've done a lot of practice, is the tangent -1. The derivative of tangent negative 1. So 1 over x squared plus 1 will result in tangent negative 1. The integral of that it would be tangent negative 1x. So right, minus, remember the minus sign, tangent negative 1x. Always remember the plus c, right? So that would be option A. But what if you don't know what to do here? It's kind of stuck, you're like, maybe you can do trig sub since there's a perfect square. Or you could like take the square root and then square it. Actually makes the problem a lot complicated. And just losing a lot of time. What you can do actually is since you have the answers, you can just take the derivative of these, right? If the derivative of one of these is this, then you should have the answer, right? That might be really cumbersome, as you might have to take the derivative of 5 things, and might not be really helpful. But it's a way to do it. It definitely takes more time, and if you don't know how to do this question from the integration side, I'll recommend you just skipping it and come back to later. Maybe you have an idea, or maybe you just have to take derivative of the answers, and then you can get this original equation, right? For this question, but it's pretty nice because you take the derivative of a, right? You take d dx of option A. Right, plus c doesn't matter here since that's gonna go to 0 anyways. That's just equal to 1 minus 1 over x plus 1, and then you put this on top. Right, the x goes away. The plus 1 minus 1 goes away, and then you get that. That's pretty lucky. Right, it might be option E, and then you have to go through 4 different derivations. But it's one way to do it. For number 3, we have integral of cosine and sine. This is a typical trig integral. In this case, since we have sine x in a square root, that's pretty hard to get out. So what I'm gonna do here is convert a cosine square into sine square, or 1 minus sine square. Right? So we have the central trig identity, right? I can convert this into 1 minus sine squared. I have cosine, and then I have a cosine square, which I will write as 1 minus sine x squared. And then I will write the square root as 1/2. Distribute times 1 cosine square cosine x times 1 times sine square root minus cosine square sine square times sine half will be 5 over 2. Oh, sine 5 over 2 dx. And now I can use sub with u being sine x, then du will be cosine x dx, right? Since now we have the cosine x dx for both of those terms, I can separate this to actually 2 integrals. We have dx here. So now this is u square root of u, which I can write as u to the half power du minus, this will be u to the 5 over 2 du. Right, chain rule. Minus, that would be 2 over 7 u 7 over 2. right? And then we can plug the sine back in for u. Sine minus 2/7 sine 7/2x. Remember plus c, of course. And that'll be answer E. Remember the minus sign, pretty important. For number 4, we have to take the integral of tangent negative 1x. When I first saw this question, I thought it would just be 1/x² plus 1. But then I realized that's the derivative of tangent negative 1, and I'm pretty lucky that that's not one of the answers. I would have definitely chosen that. But looking at this, it's sort of unclear what to do at first. But when I sort of look at the answers, especially C, D, and E, I kind of realize this is like a answer for like a biparts question. And this is actually pretty sneaky because you can have biparts, where you have like one part, right? You can have tangent negative 1, and the other part can actually just be 1 times 1, right? Now we have a pretty good biparts, and we'll still use that. Right, we have the derivative of tangent negative 1 would be 1/x² plus 1. Well, with that knowledge, we can say that our u for biparts can be tangent negative 1, since we know the du for that is x² plus 1. Now, u or v would be dv would be our 1 dx, and then v would be just x. Now we can write the biparts, right? So the integral will be uv minus v du, which would be tan negative 1x times x minus integral of v du, should be a dx here. And then you can't really combine the first terms together, but this would be square of x dx. I can u sub here, whereas the bottom would be my u, and then 2x dx will be my du. Or you can say x dx equal to half du. So in that case, this would be 1/u and then 1/2 du. The first part stays the same, and that will be a fourth? No. 1/2 ln u plus c. Then we have 1/2 ln plugging in x² plus 1 plus c. And that will be answer choice C here. And I guess this question is just more of the realizing biparts can easily solve this question. Right? You should always look for u sub as the easiest way to sub integrals, and then anywhere you can use biparts. That's pretty simple too. And then the other ones. And realizing that biparts you can have like a times 1, and that would be like a constant that you can use for dv, right? But if you use 1 for u, that's questionable, because then du will be 0, and that's not very helpful. For number 5, we have a physical application of integrals. So we have a swimming pool rectangular prism, pretty long, 50 meters standard, Olympic sized, 25 meters wide. Say that's 25. Not drawn to scale. And height is 2. And we are assuming that this is pumping out, right? So water, there's like water all in here, and we're pumping outwards. So I'm gonna assume that it's pumping outwards through the top. Right, in that case, I'm gonna say the direction here is y, as x, y, and z, y goes upwards, and the variable I'm going to use for the height is going to be y. So we're concerned with work, and work is the force times a distance times the distance that this has to travel. In this case, it will be 2 minus y. So what I'm saying here is for the y layer, like a y layer water, the layer of water that's at y, which is changing, it's gonna go through, the distance it needs to go through is 2 meters minus y, right? It's the distance away from the top. And then there we will have our limit integration will be 0 to 2, as in the water starts from when it's at 0, goes to when it's at 2 at the top. And then, of course, dy for the layer of water. Or rather, dy comes in later, because it's the height of the water. But so the force then we have is force of gravity, which equals mass times g. The 10 for acceleration due to gravity, and then mass in this case would be length times width times the height. In this case, we're concerned with a layer of water, and that will be our dy coming in, and that, right, length times mass times height will be the volume of that layer of water, and that we need times the rho, the density, to get the mass. So we can write this all together, right? We have work equal to integral from 0 to 2, force is mass times g, which in this case would be the length is 50 meters times width of 25 meters times dy, which I write in the back. Rho is 1,000 kilogram over meter cubed, and then times 10 meters per second squared times 2 minus y, and then times dy. So if we look at the units here, we have meter, meter, meter will cancel out the meter cubed here, and then there should be a meter here since that's the distance it goes through, right? And there's a meter here. So in this case, it would be the final unit I have would be meter kilogram per second squared, which would be, this would be like a force, and then I have one more meter left, right? It would be force times meter, which would be work. So I have all the components due to unit analysis. All right, and I sort of want to draw attention to how the answers are written. You notice that like all the 25s are like here. So that's what I'm going to do. I'm going to try to create 25s and leave the others intact. So here, work, I'm going to bring all the constants outside. So these blue markings, that's at 50, 25, 1,000, and 10, all constants. So the 2 is also a constant, but I'm going to leave it there for just for integration sakes. So we will have 50, which is 2 times 25 times 25 times 1,000 times 10,000 rather. Combine the 1,000 and 10, right? And then integration of just 2 minus y dy. So 20,000 times 25 times 25 times, in this case, would be 2y minus y squared over 2. All this evaluated from 0 to 2 be 20,000 times 25 squared times, it'll be 2 times 2, 4 minus 2 squared will be 4 over 2, 2, and then it'll be plus 0 minus 0, and then in the end this will be, so that's a 2. I'm gonna multiply it with the 20,000, so 40,000 times 25 squared, and that will be in joules. It's a bit of a weird question with how the answer is. Oh, wait, that's not the right answer. How the answer is formatted, it should be D, 25 squared, not 25 cubed. For number 6, we have just another integral, and this one is pretty typical of a partial fractions because you can actually factor the bottom, the denominator out, right? X squared plus x minus 2, let's just be minus 1 plus 2, right? So then we have partial fractions in the form of a of x minus 1 plus b over x plus 2. Right, that's what this equals to. And then I'm just gonna cross multiply in the sense that get back to the original fraction, b times x minus 1 will equal to x plus 5. Right, so we have ax plus bx. All the terms of x of the first power equal to just x, right? And then we'll have the constant terms, 2a plus, or minus b rather, will be our constant term 5. Right, and then we can divide the x out on the equation 1 here. So we have a system equation, and then right, we have a plus b equal to 1. So I'm gonna do equation 2 plus equation 3. So then it will be 2a plus a minus b plus b equal to 1 plus 5 is 6. So we have 3a equal to 6, a equal to 2, b then is negative 1 if I plug into equation 3 here. So we then have integral from 2 to 3. That would be 2 over x minus 1 plus, or negative 1 over x plus 2 dx. Right, this is just pretty simple for just use natural log. Right, we'll have natural log of x minus 1 with 2 in front minus natural log of x plus 2. All of that is evaluated from 2 to 3. And then I'm going to plug 2 and 3 in, so we have 2 ln, that'll be 2 inside. Let me just write it using parentheses. ln 2 minus, that will be ln 2 plus 2 is 4. And then it'll be minus 2 ln 2 minus 1 is 1, minus ln 2 plus 2 is 4. And then we have, what we can do is move this 2 inside, it will become the power inside, right? So we have ln 2 squared minus ln 4 minus ln 1 is 0, so all this is 0, plus ln 4. Wait, that should be ln 5, because it's 3 plus 2. Right, and then it would be 1 and 4. Right, and then we have ln 4, 2 of them in fact, minus ln 5. Well, in this case, we can again move the 2 inside, become the square, a 4 to 2 power, so it'll be ln 16 minus ln 5, and we can combine the logs together in division, right? So I would try to familiar myself with the log rules, right? The log identities, and how you can take the power from outside the log, and then you can move it to become the power of whatever is inside the natural log, right? These are important identities, and to get to the final answer in the simplest form, which is, I think, what you need for this question. For number 7, we are asked to use trig substitution to solve the following integral, and we need to use either sine, tangent, or secant as our trig sub. So with that in mind, this equation here, right, this is pretty typical of trig sub. In this case, since it's a minus sign inside the square root, that means that we got to set x to be the hypotenuse. Right, if I want the angle to trig sub with to be this angle, that means that I'm gonna have to set the 1 to be here, because in that case, secant x will be equal to secant theta. It's just 1 over x, right? It's just the inverse of cosine, which is adjacent over hypotenuse. So that's the general reason why. And the opposite of that theta would be x squared minus 1 and square root of that. Now we have our conversion. We need to find the dx, and then the derivative of secant theta would just be secant theta tangent theta, d theta. Now we can plug this all in. So we don't know the limits of integration yet, but we will have, so x cubed would be just secant theta cubed times, we can replace the square root part with just simply sine theta rather. No, tangent theta, which would be opposite over, right? Opposite over adjacent would be tangent theta. And then that times the dx part, which is secant theta tangent theta, d theta. Right, then one tangent theta cancels out, and one secant theta cancels out. Then we have 1 over secant squared, which we can flip. The inverse of that is cosine, so it'd just be cosine squared of secant, or of theta, d theta. Now, if you notice in the answer, all the options are actually cosine squared theta. So actually, we didn't need to find this part. If you actually look at the answer first, and you will realize that we don't actually need to solve the integral. This question is more about just solving the limit of integration, which we don't need to do, like this whole part, right? All we needed was x equal to secant theta, right? But nonetheless, if I have x equal to secant theta, and I say I want the data for the limit of integration as x, so I want to solve theta for x equal to root 2 and 2, right? So we say x, or rather theta, will equal to secant negative 1 of 2 for the upper limit. I can call it secant 2 for the upper limit, and secant 1 would be the same thing but for root 2. Now, if you memorize these, that would be really great. You can instantly get these. But if you didn't, these are really nice numbers, right? Usually you look at like cosine and sine, and it's like some decimal or like some like non repeating decimal. But 2 and root 2 are really nice numbers. So and these are triangles you should know, right? What this is saying is that there is a triangle with an angle like a cosine of the angle is equal to 1/2, right? If I invert it, and this is saying the cosine of an angle is root 2. All right, these should ring a bell. 1/2 of root 2, right? One triangle is the famous 30, 60, 90, where it's the opposite of the sine of 30 is 1 over 2. All right, and then it's root 3 over here. So this 1-2 relationship is what we're looking at. And the cosine of this angle would just mean that it's the 60-degree angle, whereas the adjacent side is 1/2 of that hypotenuse. So for the upper limit, we have 6 degree. In our case, since it's all in radian, it's pi over 3. The other triangle is the 1 root 2. Right? We have 45 isosceles. And then in this, same thing. Root 2 here, that should be 1. So then here, theta should be 45 degrees, which is pi over 4. And it seems like option E will be our answer then. For number 8, we have a partial fraction expansion or decomposition as it says here. And let's just get right into it. So for A, we need to multiply top and bottom by x minus 1 squared to get to the original denominator. For B, we just have to do x minus 1 squared. And for C, we'll have x minus 1 times x squared. And finally, for D, we'll have to multiply by just x squared. So go do that. Right? A, we have A times the black part, and then plus B times the blue part, plus C times the red part, plus D times x squared will equal to 1. It's just combining all these fractions together under a common denominator, and then the result of all that added together would be the numerator of the original fraction. So here, I'm just going to say x minus 1 squared would be x squared minus 2x plus 1. So then I have a times x squared, x cubed, minus 2ax squared plus x would be the first one, and then plus bx squared minus 2bx plus b, and then moving on to c, we have just cx cubed minus cx squared plus dx squared equal to 1. So now I'm gonna separate these all by their power. So here's x cubed, we have x squared, and then the x's, and then b would just equal to 1. Right? That's the only constant term we have, and on the right side, that's the only constant term we have, right? All other should equal to 0. All other power, the multiplier, all the constants should all equal to 0. As what I mean by that is, right, ax cubed plus cs cubed equal to 0 x to the third, right? And then we can just erase all the x cubed out. So we have a plus c equal to 0. And similarly, we have all the red x squares. So we have negative 2a plus b plus c, minus c plus d equal to 0. That's all the square terms. Since there's no square term over by the original fraction. And lastly, we have the blue ones, the x's, a minus 2b equal to 0. Right? I'm gonna maybe use orange here. So this will be equation 1, 2, 3, and 4. We have a 4-variable system of equation. So if I plug in 1 to 4, then we have a minus 2 times 1 equal to 0. So a equal to 2. And then I can plug this into equation 2. So then we have 2 plus c equal to 0, c equal to negative 2. And then plug all that in for equation 3. I will have negative 2 times 2 plus 1 minus negative 2 plus d equal to 0. So negative 4 plus 1 plus 2 plus d equal to 0. So that will be negative 1, so d equal to 1. So then a plus b plus c plus d will equal to 2 plus 1 minus 2 plus 1, which is 2. For number 9, this is an improper integral, so I'm going to start off just running the limit of like a extra variable b here, approaching infinity, and I will have 0 and b as the limit of integration then. But looking inside the integral, I would probably use biparts since there's x and a exponential form. So Laitier, a comes before e as for algorithmic, or rather algebraic, and comes before exponential. So for that, I will write u du v dv. So I have x, the algebraic term, as u. So in turn, 1 dx would be my du, and then dv would be the exponential term, dx, and then negative 1/5 e to negative 5x will be my v. Remember the chain rule. So now I can write this as uv minus v du. So we have x times -5 e to the -5x minus v, which is -1/5 e to -5x times du, which is 1 dx. So this would be, I'm going to move the -1/5 up front, x e to the -5x, and then that will be plus 1/5. I'm going to move the constant outside, and then chain rule again, we will have -1/5 e to the -5x when I solve the integral, and all of this is evaluated from 0 to b for now. So now I'll plug in 0 and b. So for x, and then let's see, is there a simpler way of writing this? I can combine the -1/5, and the e to the -5x together. So we have -1/5 e to the -5x, and then the rest will be x plus 1/5. From 0 to b. And then I can say -1/5 e to the -5b. Actually, I want to write this in fraction. So 1 over e to the 5b times b plus 1/5. All this is minus -1/5 e to the 0, plugging 0 in, and then that would be 0 plus 1/5, which is 1/5. So here, here we can take the limit back here. Limit of this, b plus 1/5, and then it would be e to the 5b. So in this case, since e to the 5b grows a lot faster than b does, right? The blue part grows a lot faster than b plus 1/5. So this part approaches 0. So this whole front here is just 0. And then, so we only need to calculate for the latter part. And e to the 0 is 1. And double negative would be a positive, and we'll have 1/5 times 1/5, which is 1 over 25. For number 10, we have 3 statements about improper integrals, which we need to determine which are true and false. So for number 1, we have from 0 to 1 ln x. So this is improper because ln x approaches infinity. That should be a smooth line. When it approaches 0, it approaches negative infinity. So that's something we need to deal with. So that means that instead of 0, I'm going to take the limit of b approaching 0 from the positive side. Since we are dealing with the positive region, And this is one of the integrals that does not equal to 1 over x. That's the other way around. The derivative of ln x is 1 over x, and this is one of the integrals where you have to make by parts work. What I mean by that is just slap a 1 here times 1 dx, and now you have two parts, and I can say u du v and dv, and ln x is logarithmic, so I'm gonna use that for u. And turn du would be, that should be u. Du is 1 over x dx, and dv would be 1 dx, whereas u then would be x. So now I can write uv minus v du. So we have ln x times x, and then minus x 1 over x dx. So here the x's cancel out, right? And then would just be integrating of 1 dx, which is just x. And all of this is from bounds, that should be b up here, b to 1. And when we plug in 1 and b, I'm just going to write the limit back here. We have ln 1 times 1 minus 1 minus ln b times b minus b. Right, ln 1 is 0, so this whole part is 0. So then I can move the negative 1 out, right? This 1 also goes with 0. So negative 1 plus limit of b approaching 0 from the positive side. We have ln b times b. For the minus b part, I can just say that's just 0, minus 0. But I'm really concerned with this part because I don't know what this is. Right? If you plug in 0, it's ln 0, that's still negative infinity times a 0. Right? Infinity times 0 is not very pleasant, and we don't know what that is yet. And the best way to solve this is with L'Hopital's rule. So I need to create a infinity over infinity situation in a limit. Then I can use L'Hopital's rule. So this would be negative 1, move a little bit, negative 1 plus the limit of b approaching 0 for the positive side. What I'm going to do is I'm going to keep ln b on top, and then I will divide by b on, as in if I have a fraction like this. So in that case, the top b will just get moved to bottom as 1 over b. And now, if I plug in b, the top part is still a infinity. Right? It's a negative infinity. And this would be negative infinity over 1 divided by 0, which is infinity when taken in the limit. So now I can use L'Hopital's rule, where I take d dx of top and bottom, or rather d db of top and bottom, still keeping the limit. The top part is now 1 over x, right? That's the 1 over b, That's the 1 over b derivative, and then the bottom part is just negative 1 over b squared. Right now, what I can do is multiply a b on top of bottom and get rid of this. Or I can multiply actually top and bottom by b squared. Then I will have b on top, and then just negative 1, which is just, I can just say it's negative b. Now this limit we can take. It's just you plug in 0, and that's just 0. And this means that this integral, this improper integral, does have a value. Therefore, it's convergent, and the statement we have is false. I need to delete all that. So number 1 is false. Now number 2 and 3 are tied together with the sort of central equation you should know for improper integral, right? The integral from 1 to infinity of a polynomial in a fraction, so x to p, right? When p is more than 1, this is convergent. Converge. Right? When p is less than equal to 1, less or equal to 1, then this is divergent. So that's a rule you should definitely remember. It comes in handy in here directly as the question, or it might be in comparison tests when you compare it with other improper integrals. But then in this case, number 2 will just be true because that's just what the statement says. And then now number 3, right? I can rewrite this as 1/2, right? X to 1/2 power for the square root. And now this p, in this case, as p is less than 1, right? 1/2 is less than 1. That means that this is divergent. Therefore, number 3 is also false. For 11, we have 3 sequences, and we determine if they are convergent or not. So for number 1, we have n squared on top and the third on the bottom. So determine their convergence. I'm going to take the limit of n approaching infinity. In this case, the plus 1 in the bottom is not going to matter as much as this just approaches as n gets infinitely big. This just is n squared over n to the third. So that would be 1 over n, as n squared can cancel out top and bottom, and thus this limit will equal to 0. And the other way that you could think about this is, since there's a n cubed in the bottom and n squared on the top, that means at the bottom, the denominator is going to grow much faster than the numerator. Therefore, it's going to approach 0 in that way. So number 1 is convergent, as it does have a value to its limit, and that is convergent. And number 2, for number 2, what I'm going to do is a little differently. I'm going to just write out a couple of the sequences, numbers within the sequence. So for the first number of the sequence, we have 1 plus -1 to the first over 2, which is 1 plus -1, so it's 0. And then we have 1 plus -1 squared. So that would be 1 plus 1, so it's 1. So it's 2 over 2, which is 1. And then it oscillates, right? At every odd power is going to be 0. And every even power is going to be 1. So there's a pattern as this sequence oscillates between two numbers. And since this sequence does not like approach a number, right? It's between two numbers. It's always just 1 or 0, 1 or 0, 1 or 0. So therefore, the sequence does not converge to a number, right? We know what the sequence is, but we just cannot conclude that this converges. So number 2 does not converge. For number 3, again, we can use the limit of n approaches infinity of cosine n and n plus 1. We can look at this two ways. For cosine, a cosine graph will look something like this, right? A general shape. It's a sinusoid that is between -1 and 1. That's the most important part, right? So no matter how big this n gets, no matter how big like this x approaches, right? As x approaches infinity, y will still be within the range of -1 to 1. And that's the important part because therefore the numerator here is always bounded between -1 and 1. But the denominator, n will just approach infinity, right? So this is essentially saying it's like 1 over n, or in a sense, right? It's like some number between -1 -1 to 1. Right, as this bottom is just going to be infinity. So therefore, this limit will come out to be 0 as the bottom approaches infinity. So the sequence number 3 also has a limit, therefore it converges. For number 12, we have 4 statements, and we have to judge if any of these are right. So for number 1, we have the limit of 1 plus the limit of n approach infinity of 1 plus 1 over n to the n. This, you can't really simplify this, but just as a general thing, right? This is 1 plus something. This something might be really small, but it's like something, and you like 1 to the infinity is still not going to be 0. So from just like a guessing standpoint, like I can guess that it's definitely not 0, right? It's not right. But we can go through and maybe work some algebra and see if we can come up with something else. So I'm going to combine these fractions, right? That was just 1 over 1. So it's n over n, and I'll have m plus 1 over n to the nth power. Now this, you can tell this is kind of, it's sort of still the same thing, which the numerator is a little bit bigger than the denominator. So I can tell that it's a little bit more than 1, right? By comparison test, this is more than 1, more than n over n, which is equal to 1. So this will now approach 0, right? It will approach something bigger than 1. But if you actually have done enough problems, you will realize this is actually the definition of E. this actually equals to e, and it's I think it's the first someone in history wrote e as in this in the first attempt to solve something, but this this limit actually equals to e, which is not 0, which means the first one is not correct. And then we have the limit of e to the negative n, right? I'm gonna write that in the denominator with a positive power. Right now, we can say that this infinity, when plugged into n here, right, e to the infinity is gonna be approaching infinity, right? That means that 1 over that infinity is gonna be approaching 0, which is then it's correct, right? It's 1 over infinity, and then approaches 0. So number 2 is correct. Going on, number 3 concerns with tangent -1, which I think you can think of it as the other way. You can think about tangent, which is where you draw a triangle. Tangent of theta is opposite over adjacent. So this tangent is saying that when this relationship of opposite over adjacent, right, is infinity, right, because there's like a certain angle that we don't know has the value of infinity, or its approach is infinity. That means that the opposite over adjacent is approaching infinity. Like this relationship between opposite over adjacent. And if you can kind of imagine like a triangle with a really small, infinitely small width, but a really tall, let me see, I can draw a straight line here. A really tall opposite side, right? It's gonna be something like this, right? This is the angle right there. And it's so tall that you can kind of tell this is gonna be like 90 degrees, right? It's basically the opposite and the hypotenuse just kind of combine into one, whereas this blue line here, the opposite line, is infinitely big. That's how you get infinity, right? And then this angle that's in between is gonna just approach 90, which is pi over 2. But if this doesn't make a lot of sense, another way you can just graph tangent. If you know what tangent looks like on the graph, or tangent -1, it's even better. Tangent looks something like this, right? With pi over 2 here and negative pi over 2. And now you can kind of see the inverse, right? I'm trying to find a angle that equals to infinity is what tangent -1 is, right? So the part that approaches infinity is at pi over 2, right? And then, of course, if you know what tangent -1 is, it's just the inverse of that, which is like this, right? Now it's just simply this is tangent -1 of x, this is y, right? And then now you can just see that as x approaches infinity, y equals to pi over 2. Many ways of doing that. So number 3 is correct. And then number 4, as n approaches infinity of n over n plus 1. So as n approaches infinity, this n plus 1 is not going to matter as much. And that means that we can just drop it. and that would be n over n, which would be limit of 1, which equal to 1. Right? But what is the difference between this one and this one, right? Since one, like this one, the number 1 equals to e, this one equal to 1, right? That's the difference because there is a power here, right? If I have a limit of this, then that's different. That's not 1. That's actually 1 over e, right? Because although it will at infinity, the numerator and the denominator is infinitely close, but there's still a small difference, and that small difference gets magnified through the nth power, right? And the nth power here signifies like n. I'm taking this difference and multiplying it infinitely times, which comes out to be e, which is some magical number that we deal with a lot. So that's the difference between having that power and not having the power on number 4. But number 4 is correct. It is 1. So now we have 3 correct answers, 3 correct statements. Thank you for watching this video. The past exam archive and all the videos I did related to this exam will be linked in the description below. Please check them out if you're interested. Thank you.